Let's see. In 33, we have f of x is equal to square root of 4 minus x squared from 0 to 2. Now if I were to graph this, so this comes up. I apologize for the video or the audio on this. Let me use my old mic. Okay, so if I go to the y equals, clear, square root of 4 minus x squared, and then graph. And we're looking from 0 to 2. So we're only looking at the right side here. So our graph looks like it goes up to 2 also. Our graph looks like this. That's our f of x. Now you were asking, how can the function and its inverse be the same? Well, if I wanted to find the inverse of this, what you do is you'd flip it across the line y is equal to x. Well, if I take this piece right here and reflect it, flip it across that line, it would land right on this piece. If I take this piece down here, flip it, reflect it across this line, it would land right on that piece. That's why the function and inverse are the same in that problem. But we're going to go through our steps. First step is we're going to replace f of x with y. So I got y is equal to square root of 4 minus x squared. Step 2, you swap, interchange x and y. So you got x is equal to the square root of 4 minus y squared. Step 3 is you solve for y. Well, this is a radical equation. So we get a radical by itself, which we already have. Raise both sides to a power equal to the index. This is a square root, so we'll take both sides to the second power. So then we get x squared is equal to, and when you square a square root, they cancel each other away, so that gives us 4 minus y squared. Now we want to get the y by itself, so I'm going to take the negative y squared, move it to the left side, and I'll take the x squared, move it to the right side. So I got y squared is equal to 4 minus x squared. And the square root property says if you got something squared equals something else, you drop your squared and you put a plus or minus square root on the other side. Step 4. Replace y with your inverse notation. So the inverse of f is equal to the plus or minus square root of 4 minus x squared. But there's a problem with that. We cannot have plus or minus on that. That's not one-to-one. So our last step is we have to make it one-to-one in some form. Well, if I think about the inverse of our function, we've already talked about this. If I take this piece here and flip it across this line, reflect it across that line, it would look like that right there. Now if I were to take that original black piece down here and flip it across this, it would look like, let's choose a different color. It would look like that right there. So I know that not only is my function that same graph, but my inverse is also. But even more than that, plus or minus. If I go back to the previous step, this says y is equal to plus or minus. Well, nowhere is my graph down here, so y cannot be negative, which means I'm going to drop the negative portion and I'll keep the positive portion. Now they do something additional to that. That's really your inverse, but they'll also specify the domain where this is valid at. And it's actually the same as up here. It's valid between 0 and 2. And that's how they get the inverse.